Find the points of intersection of the circle x squared plus y squared minus 6x plus 2y minus 17 equal to 0 and the line x minus y plus 2 equal to 0. Show that an equation of the circle which has these points as ends of the diameter is, that equation. Now show also that the circle and the circle x squared plus y squared minus 8x minus 2y minus 13 equal to 0 touch externally. We are going to find the point of intersection, which is simply working out this question as a pair of simultaneous equations. So we have here x squared plus y squared minus 6x plus 2y minus 17 equal to 0. And then we have x minus y plus 2 equal to 0. This can be named as equation 1 and 2. I'm going to use the substitution method, so I'm going to make x the subject or even y the subject over here and substitute it into equation number 1. So to make y the subject, we add y to both sides, and then we would have positive y being equal to x plus 2, right? So then in equation 1, we should get x squared plus x plus 2 squared minus 6x plus 2 times x plus 2 minus 17 equal to 0. Let me just map this out now before it's too late. Okay, then this will give us x squared plus x squared plus 2 times x is 2x, so we have 2x's, which makes 4x plus 4 minus 6x plus 2x plus 4 minus 17 equal to a 0. Then we bring the like terms together. So I'm just going to color code this x squares. That will be x squared. Then we have x's, 4 minus 6 plus 2, which is a 0, cancels out, so 0x. And then lastly, the constants, which are 4 and 4 again. 4 plus 4, which is 8, minus 17, that will be a negative 9. So x squared minus 9 equal to 0. Oh, this first one, x squared plus x squared, has to be 2x squared. And then now we can work out x, which would be equal to 9 over 2. So x would be the square root of positive and negative 9 over 2. Simplify that again. X would be positive negative 3 over root 2. Rationalize the denominator. Positive or negative 3 root 2 over 2. When x, I would like to change the color. When x is equal to positive 3 root 2, what is the value of y? Y is just the value of x. Oh, that should be over 2. So 3 root 2 over 2 plus 2. Get a common denominator. Y would be equal to 3 root 2 plus 4 over 2. And then when x equal to negative of 3 root 2 over 2. I'm saying something else and writing something else. Negative 3 root 2 over 2. We would have y being equal to negative 3 root 2 over 2 plus 2 again. Okay. Minus plus 4 over 2. So these are the points of intersection. Let's move on to part number 2. Show that an equation of the circle which has these points as ends of a diameter is equal to this. So if you have a circle, has these points as ends of the diameter, it means that one point, if we remember quite well, when x was positive, we had 3 root 2 over 2, comma, what was the value? We had positive as well, so we had 3 root 2 plus 4 over 2. The opposite side, we're going to have, so I'm just going to bring this here, negative 3 root 2 over 2 should give me negative 3 root 2 plus 4 over 2. And there we have it. So for us to find the equation of a circle which has endpoints as diameter, we first of all need to look for the center, which is called the midpoint at this point, basically. Center. And then what else do we need? We need the radius. The radius is equal to half the distance from point 1 to point 2. Okay, let's just call that D1, 2, just like this. Okay, so the center is the midpoint, so we're basically going to add corresponding coordinates, divide them by 2. All right, it looks very cumbersome because they are huge fractions. So 3 root 2 over 2 plus negative 3 root 2 over 2. All of this you add it up, divided by 2. And then for the y, we should get 3 root 2 plus 4 plus, okay, let's erase this, plus negative 3 root 2 plus 4 over 2 over 2. You add them both, you divide that by 2 to get the midpoint. Center would be equal to, this one is going to give me a 0. And then this one, since they have the same denominators, we can see that this 3 root 2 is going to cancel out, yes? And then we would have 4 plus 4, which is 8. So this is 8 over 2. Then we divide by 2. So we divide this by 2. So 8 divided by 2 is 4. 4 divided by another 2 is 2. That is the center. And then I'm just going to go ahead and restart this. Okay, next thing we want to find is the radius, which is half the value of the distance between point 1 and point number 2, right? Okay, or it's just the distance between point 1 and the center, or point 2 and the center. See that? So point 1 and the center, or point 2 and the center. So I'm just going to work it out directly rather than working the whole thing out and dividing by 2. Okay, so let's find the distance between point 1 and the center, which was 0, 2. Don't forget, you can also use your formula booklet. You subtract both of the corresponding coordinates, square them, take the square root, y1 squared. Keep in mind the order does not really matter, because when you square it, it should give you a positive number always. All right then, so we are finding the distance between 3 root 2 over 2 and 0, comma 3 root 2 plus 4 over 2 and 2. I just had to put this like so, so that I can align it. You know, when I align them, it's easier to see what I'm subtracting. X and X, Y and Y. So D1C is equal to X2, so 0 minus 3 root 2 over 2 squared plus 4 over 2, all of this squared. Okay, so the distance would be, this one is just going to be positive. So I'm just going to square 3, which is 9, square root 2, which is 2, square 2, which is 4, plus, well, here, common denominator, 4 minus, please put these in brackets because you can easily make a mistake and forget that you are subtracting all 8 terms. So they're all going to become negative. So 3 root 2 minus 4, like so, over the 2. Okay. So now you see that the 4 cancels out. Yeah. And then when you square it, what happens? It gives you exactly the same value as the first one we had. Okay. So this would be D1C equal to square root of 9, well, simplifying this is going to be 9 over 2 plus, I said will still be 9 over 2. That gives 18 over 2, which is still 9, or square root. So the diameter, sorry, the distance is a 3. And finally, we can say that the radius of the circle would be a 3. Now, how do you get the equation of the radius of a circle? We have the general formula, x minus h squared plus y minus k squared equal to r squared. H and k, let me just make this clear, h and k would be the center, which was 0, 2. Substituting this, x minus 0 squared plus y minus 2 squared equals 3 squared. So x squared plus, well, FOIL method again, y squared minus 4y plus 4 should be 9. Bringing this one to the right hand side, or the left hand side, pardon me, will be x squared plus y squared plus 4 minus 9 minus 4y equal to 0. And then finally, x squared plus y squared minus 4y minus 5 is equal to 0, which is the equation that they had in the beginning. Let's check to see if it is as required, because when I was working this out, I noticed that some of the questions had typos. So you see here they have a positive, and I worked this out a couple of times and I got negative. Okay, so this is just the difference right here. That's the equation of the circle. Last section, show also that the circle and this particular circle, they touch externally. So the condition for two circles to touch externally, let's say we have this, let's take a look. There we go. They're touching externally. What do you notice? The radius, or the radii, r plus r, should be the same as the distance between their actual centers. So we have to find the center of this circle. We're going to work out the center using completing the square method. All right, so this would be x squared plus y squared minus 8x minus 2y minus 13 equals 0. To complete each of the squares, let's first of all bring the x's. So x squared minus 8x plus y squared minus 2y, and then we isolate the constant. Okay, completing the square, you find half of 8, square it, add on both sides. So half of 8 is 4, like so. Add on both sides, half of 8, negative 8. Keep in mind the sign matters. Square, and then plus y minus 2y would be plus negative 1 square equals 13 plus negative 4 squared plus negative 1 squared. Completing the square, we bring these together like so, and then we should get x minus 4 squared plus y minus 1 squared equals 30. We can now compare this to the actual equation of a circle, which I have over here, to see that the center would be equal to 4, 1, and the radius should just be the square root of 30. Okay, so show that the circle and this one, so the circle, which is which one, is it has to be the original one, either this or even this one. So we are going to start logically with the one given in the question, okay, because that's how it goes. You go with the original. So we're gonna try to find the center of the original one. The original circle was x squared, so original is x squared minus 6, x squared minus 6x plus y squared plus 2y minus 17 equal to 0. Again, using completing the square method, this would be x, well, I don't have to explain a lot again, so x minus 3 squared plus y plus 1 squared should be equal to 17 plus 3 squared plus 1 squared, which gives me a 27. So 27, just like this. Okay, center 3, negative 1, radius is root of 27. Okay, then we would have to show that the sum of the radii is equal to distance between the circles, the centers, pardon me. Okay, here this is center 1, center 2. Find the distance between C1, C2. That I should get 4 minus 3 squared plus 1 minus 1 squared, square rooted. That would be 1 squared, which is 1, plus 2 squared, which is just 4. So 1 plus 2 squared is 4, which is the root of 5. And then now the sum of their radii, radii 1, radii 2, should be root 30 plus root 27, which is 5.4 plus 5.196, which is 10.6. And what do we notice here? That this perimeter is not equal to a center. I know you're wondering why. Well, I had done this question, like I said, a couple of times, and I noticed that there was a typo in this question, but at least I decided to show you guys the working because you would have to understand how circles touch externally. You still gain some knowledge, even though they are not equal. That's about it. Moving on to question number 10.